Unit 4, Lesson 9, Comparing Graphs. Learning target number 1, I can compare the features of graphs of functions and explain what they mean in the situations represented. Learning target number 2, I can make sense of an equation of the form f of x equals g of x in terms of a situation and a graph and know how to find the solutions. Learning target number 3. I can make sense of statements about two or more functions when they are written in function notation. Functions r and d give the height in feet of a toy rocket and a drone t seconds after they are released. So, when we see that the functions give, the very next thing is our output. And we can see right here, height in feet is our y-axis. That means seconds after they are released is our input, and we can see time in seconds is our x-axis. Here are the graphs of R for the rocket and D for the drone. Write each statement as function notation. So remember that function notation is written as name, input in parentheses, equals output. So, number 1, at 3 seconds, the toy rocket is higher than the drone. So the function for the rocket is capital R. The input is the time in seconds, and they'd want 3 seconds. So that's capital R and 3 in parentheses. And we want this to be higher, which means greater than, the drone. And it tells us the drone function is capital D. And that is also at an input of 3 seconds. So capital R of 3 is greater than capital D of 3. Number 2, at the start, the toy rocket is 25 feet above the drone. So if we have the toy rocket, which is R, at the start, which means 0 seconds have gone by, that would equal the drone at 0 seconds plus 25 feet. So always remember that give, the very next thing will be your output. Your output is your y-axis. Your input is your x-axis. And anytime you write function notation, you have the name of the function, which can be lowercase or capital case letter. You have the input in parentheses, and it's going to equal the output. A of T is the average high temperature in Aspen, Colorado, T months after the start of the year. M of T is the average high temperature in Minneapolis, Minnesota, T months after the start of the year. Temperature is measured in degrees Fahrenheit. So we can see that our output is the predicted temperature in degrees Fahrenheit, and our input is the month of the year as a number. So January would be number 1, February number 2, all the way until you get to December at number 12. Which function had the higher average rate of change between the beginning of January and middle of March? So, Aspen, or A of t, is the blue function. So, from January until March, middle of March, we're looking at this change right here. And for Minneapolis, the red line, we are looking at the change from here until here. This one does not require us to solve mathematically because both cities end up around the same temperature in mid-March. But what you'll notice is that Minneapolis started about 10 degrees lower. So if they both end up in the same temperature, but Minneapolis started 10 degrees lower, that means Minneapolis needed to increase a larger amount in the same time. Therefore, Minneapolis has the higher average rate of change. What does this mean about the temperature in the two cities? What this means is that Minneapolis's temperature changes more than the temperature in Aspen. Aspen's temperature doesn't change as much. You can see this in the graph itself. Minneapolis starts and ends the year colder, but it has a warmer summer. Aspen has a more consistent temperature because it doesn't change as much. So, Minneapolis has a temperature that changes more. Aspen has a more consistent temperature. This is how we can actually compare rates of change simply by looking at the graph rather than actually needing to calculate these answers mathematically. Here are two graphs representing functions f in black and g in green. Select all statements that are true about functions f and G. A. Function f at 0, which would be here at 0, 0, is greater than G of 0, which would be right here at 0, 14. That is false because the y value of G when x is 0 is actually greater than the y value of f when x is 0. So it's not A. There are two values of x where f of x equals g of x. This is true. One point is right here at about negative 2.15, and again here where they cross at about the point 3.110. The functions are equal to each other where they cross each other. So B is correct. C, f of negative 1, which is right here, and that looks to be about negative 1, 1, is less than G of negative 1, which is right about here at negative 1, 11. And that is true because the y value of function f at negative 1 is 1, and the value of y of g at negative 1 is 11, and 1 is less than 11. So C is also correct. And finally, D, the function of f at negative 3, which is this point here at negative 3, 9, is greater than G when x is 4, which is here at the point 4, 6. And that is also true. Because the value of f when x is negative 3 is 9, but the function of g when x is 4 is only 6, and 9 is greater than 6. So choices B, C, and D are all correct. When you are evaluating the value of a function, you're going to the number that's in parentheses, which is your x value, and then you are finding the y value at that value of x, and you're comparing those y values to each other. The three graphs represent the progress of 3 runners in a 400-meter race. The solid line represents runner A. The dotted line represents runner B. And the dashed line represents runner C. Number 1. One runner ran at a constant rate throughout the race. Which one? A constant rate would give us a linear graph. That is the dashed line, which represents runner C. You can see that this dashed line has a consistent linear graph all the way to the end. So that means the answer to 1 is runner C. A second runner stopped running for a while. Which one? If somebody stopped running, then their distance would flatten out because they're not getting any farther away. And we see that on the solid line, it begins to go up, and then just above 300 meters, we see it flatten out for a while until it finally starts to pick back up and finish out at the end. The solid line was runner A, so number 2 is runner A. During which interval of time did that happen? That happens from this point right here, which is about x equals 15, when the distance is approximately 310 meters, and we don't see it start to increase again until here, which is approximately 44 seconds, and the distance is still approximately 310. So this is from approximately 15 seconds until approximately 44 seconds. Number 3. Describe the third runner's race. Be as specific as possible. So the third runner would be the one we haven't mentioned yet, and that would be runner B with the dotted line. We can see that they begin running the race at a constant rate until about 26 or 27 seconds, and then we see this curve flatten off some. What's happening is they start running fast for the first 27 seconds, and then they start to slow down. And finally, number 4, who won the race? Explain how we know. In races, you win when you complete the distance in the least amount of time possible. The x-axis is measuring the time. So the winner would be runner C because they finish first at 40 seconds. Runner B finished about 48 seconds, and runner A was the slowest at about 53, 54 seconds. So runner C won because they took the least time. Again, we didn't have to calculate anything mathematically. We were just able to compare the shapes of the graphs. We were able to compare the slopes of the graphs. And we were able to compare the x and y coordinates at certain points on the graph and still answer questions without having to do any mathematical calculations. Function A gives the area. All right, we see the word gives. That means we know the area is our output in square inches of a square with side length x inches. So side length is our input. We know that our first row is x, our second row is y. And area is how much space a shape takes up. So on a square, you multiply one side times the other. But on a square, the sides are the same. So if I multiply one number times another when they are the same, that means my area is the side squared. So we'll use that to complete the table. 0 times 0 is 0. 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25. And 6 times 6 is 36. So we fill out this table by taking the input value of x and squaring it, which means multiplying it by itself. Number 2, represent function A using an equation. So remember, function notation is name. In this case, it's capital A. Then in parentheses, we put our input, and our input is x, which is the variable for the side length. And then we say that it equals the output. And the output is going to be the side length squared. And number 3, sketch a graph of function A. So we want to take each column as a point pair. The top number is your x, the bottom number is your y. So we have 0, 0. We have 1, 1. 2, 4. 3, 9. 4, 16. 5, 25. And 6, 36. And we could join these because you can have partial inches for side length, and you can have partial square inches for area. So this would be represented by a solid line. And this would be an example of an exponential function, which we will cover in the next unit, Unit 5. And the last practice problem for Unit 4, Lesson 9, function f is represented by f of x equals 5 times x plus 11. Number 1 wants us to find function f when the input is negative 2. So that becomes 5 times negative 2 plus 11. Order of operations says we do what's inside the parentheses first. Negative 2 plus 11 is 9. And now we do multiplication. 5 times 9 equals 45. So f of negative 2 equals 45. And number 2, find the value of x such that f of x equals 90. Well, we said f of x equals 5 times x plus 11, and now we're saying f of x equals 90, so we're going to set 5 times x plus 11 equal to 90. And our goal will be to get x by itself equaling some number value. 5 times the parentheses is multiplication, so the opposite is to divide by 5. And if I divide the left by 5, I must divide the right by 5. Anything divided by itself is 1. So now the left side is just x plus 11. And 90 divided by 5 is 18. We have one more step to get x by itself, and that's to get rid of this plus 11. The opposite of plus 11 is minus 11. And if I subtract 11 from the left side, I must subtract 11 from the right side so that it stays equal. 11 minus 11 is 0. 18 minus 11 is 7. So we get our answer, x equals 7. These are all the practice problems for Unit 4, Lesson 9. If you still have any questions about any of the material from this first half of the unit, please use class time to ask for clarification before we have the mid-unit test next week.